Anywho, my name is Nathan Totten. I'm a technical evangelist at Microsoft. I work mostly on Windows Azure. I focus a lot on Node.js. I do some stuff with gaming, a lot of web development. So my background's primarily in web development. I wrote the Facebook C# SDK. I've done a lot of Facebook apps before I was at Microsoft, mostly on Windows Azure. So today we're going to talk about Node.js on Windows Azure. But before we kind of dive in, who here has used Windows Azure? Okay, and who here is a Node developer? Or has played around with it a little bit. Okay, that's sort of what I thought. Okay, so you guys are looking to learn, I assume, about both Node.js and Windows Azure, or mostly Node.js, a little bit of both. Okay, cool. So this is a mix of some slides and hopefully a decent number of demos that hopefully you find interesting. So I want to start a little bit with an intro to Node, just for those who aren't too familiar with it. Obviously, you probably know a little bit about since you're here, unless the session title was so thrilling that you just couldn't resist. So Node.js is obviously JavaScript on the server, event-driven I/O server-side JavaScript, which is super exciting, right? For those of us who love JavaScript, which probably is everyone in here, I assume, since you want to use it in even more places, this is great. So really nice thing about Node.js, not thread-based. It's a single connection, or a single thread runs on your server. Very lightweight, very highly scalable. It's a couple of years old only, about 3, I guess now, almost 4. Open source, fully open source. It's run by Joyent. Microsoft got involved in Node.js about 8 or 9 months ago now. So initially, Node.js was built entirely for Linux, Unix-based machines. We got involved in it and helped them port it over to Windows. So Node.js now currently runs basically as well on Windows as it does on Linux, which is great. Quite a popular project. It's like the first or second most popular open source project on GitHub, depending on what day you look at it. So the little diagram here basically represents what Node.js is. So basically, Node runs on Windows. It runs in a process node.exe. On top of that, it's built on the JavaScript V8 runtime, which is actually the runtime that that Google built for Google Chrome. So it's essentially a modified version of that. So it's very fast, very powerful JavaScript engine. And then on top of that, your application lives. It can be a very simple app, or it can be an app made up of many modules, either yours or open source, which we'll get into a little bit more. So for those that aren't familiar with kind of how this single-threaded idea works, basically everything that happens on your server runs in this single thread, right? So nothing blocks. Everything in Node.js, or most everything, is asynchronous. You can do synchronous operations, but in general you shouldn't. You should pretty much try to do everything in an asynchronous way. Almost every API by default is asynchronous. Basically what happens is when you're going to run an operation, say when a new web request comes in, or when you want to write to a database or read a file, you do that in an asynchronous way. Everything gets queued up. And basically, this one thread that's running the Node application just keeps running through this queued work. There's a couple really nice things about that. For one, in a web application environment, every request that comes in is handled in that same way. So a request is basically queued up. In this way, Node is actually very good for. It works extremely well for very high-scale web environments. For example, one of the really great things about this is every connection is not allocating, like in say a .NET application, a connection comes in, you're basically allocating one thread, right? There's a lot of asynchronous stuff you can do, but it becomes kind of hard in a .NET app. In Node application, since you're only running one thread, basically a request, an open request, a new request, anything like that is a very small operation. Meaning on a Node application, you can get a very large number of requests. Basically, and you get a very large number of requests. It's very efficient for that. And then you can also do things like keeping requests open. So Node works really well for these type of applications that are like socket apps, long polling, a lot of connections to a single server. Each connection to a server is, again, not allocating a thread, but it's rather just allocating a single heap allocation. So it's, again, in that queue, you're saying you've got an open thread, but while that connection is not actually doing anything, it's basically free. So you can have a huge number of open connections on a web server in a way that you might not necessarily be able to do, or certainly not be able to do very easily in a more traditional application. This makes Node really good for, again, the socket, long polling, sort of very active servers. It's great for things like media servers, proxies. Really easy for JSON web services, right? Because it's just a JavaScript server. Obviously, you can build a JSON service very easily without a lot of conversion between different data types. Very good for client-oriented web APIs. Some of the disadvantages, though, or not necessarily disadvantages, but some of the stuff that's a little more difficult with Node is it's kind of early. There's not a lot of tooling for it, so sometimes things like simple forms data application, it might be a lot easier to do in a more traditional framework such as ASP.NET, just partially because you get more tooling with that. Something Node's definitely not good for is CPU-intensive work because of the way that this. Remember, everything is asynchronous. If you were to do something like encoding video, a lot of blocking operations there. Your Node server. If you were saying someone uploaded a video and you were actually encoding it on your Node server, basically the whole thing is going to stop while that operation is taking place. So anything that's a very CPU-intensive type operation is probably not right for Node. So pros and cons of why you want to use it. Everyone's probably, you guys are obviously all a little bit interested since you're here. Again, it's JavaScript on the server, which depending on your preference on JavaScript it could be a good or bad thing. But nice thing is that there's a lot of developers that are familiar with JavaScript. You can transfer those skills from both the client side to the server side. Node has a really clean, consistent API. It's pretty easy to learn, right? There's not a huge amount to it, so you can kind of look at the core, and it does sort of the common, I/O, has a built-in web server, things like that. So it's a pretty easy framework to learn. Really simple concurrency model. So that single-threaded nature of Node.js makes it very easy to learn and very easy to use. You don't have to, building a high-scale web server traditionally requires a lot of knowledge about threads, how to do things optimally. Now, to do that on Node.js, you don't really, because there is no notion of there's not really an idea of creating a different process or thread. You really don't have to know about that, so you have a very simple concurrency model. And as I mentioned, it's super good. It works super well for those long pollings, really high capacity applications. You can get potentially tens of thousands of concurrent connections on a single server. Also super modular. There's a lot, even though it's a pretty new project, there's a lot of different open source packages basically for you to build like Lego pieces, build your application in kind of the way you want to. That portion, though, also can be a con. If you're the type of developer that wants to, just pick something up and build your application in sort of the correct way, Node is pretty young in that sense. There's not a lot of standards to it. So, for say your unit testing or validation frameworks, there's maybe like 15 different modules that you can use for that. So you sort of have to pick your own. Again, it's like a big giant box of Legos, and you sort of have to pick which ones you want, which colors and shapes and such you want. So there isn't one right way to do things in Node.js. It is sort of starting to mature, so there are a few common libraries we'll talk about, we'll show, such as for a web front end, web frameworks, there's kind of the Express.js library, which is sort of becoming one of the standards. It's also pretty bare metal, right? This isn't aimed at drag and drop developers. You don't have an integrated user IDE where you kind of get a lot of things pre-baked or even have a lot of like scripting like you would with Rails development. It is much more do-it-yourself, kind of build it as you want. So it can be a little unnerving for people who are maybe used to Visual Studio and like that experience. Generally, I use like a text editor for Node, so it's again pretty basic. So as I mentioned, there are a lot of frameworks. Some of these different modules are available, are becoming somewhat of the standard. Connect is kind of your standard middleware layer. Express, which we'll actually do a demo. I'll do a demo of Express, is kind of becoming your standard web server layer. There are plenty of other ones out there. Depending on what you want to do. As I mentioned earlier, Node.js does run native on Windows. So before about a year ago, or about 8 months ago or so, running Node on Windows was a horrendous ordeal. You had to sort of configure Cygwin, try to get it working. It really didn't work very well. It was pretty slow because you're not running natively on the OS. Now it is a native Windows binary. So it's Node. You've got Node.exe. We have a really nice install experience. We also have we have IIS Node, which is actually a module that hosts Node.js in IIS 7 or above. Most modules are supported as is. So because all the modules are written just in JavaScript on Node.js, or most of them are, pretty much everything that works on Linux does work on Windows. There are a few potential exceptions. Some of the modules, the native modules, are compiled. There's now ways around that, but some of them haven't actually adapted to the kind of new way of doing things that works across platforms. So some of the modules are still only like Linux or Unix, work only on the Linux-based machines. But again, for the most part, everything's supported as is. And actually, performance is key also. This isn't some sort of hacked kind of works version like you might expect with like sometimes Ruby on Rails or whatever works pretty well on Windows, but you'll run into things that just this part doesn't work or there's a bug here or there. It runs very well on Windows, and performance is on par. Some things Windows does a little better, some things Linux does a little better, but for the most part, they both they're sort of they're equal citizens, which is great. As I mentioned, really simple installer. So it has an MSI installer, installs Node.js, plus the Node package manager is now part of Node.js. We also do have bundled installers for like all our Windows Azure tooling. You can use our web platform installer to actually download and install those all in one click. So it's super easy to get started. So Node package manager, similar to NuGet or Ruby Gems. Basically, this package manager you use through the command line to install your favorite packages. We'll run through a few demos that have this, but it allows you to basically build all those. There is a very nice single basically repository where all of these modules exist. So even though it is pretty new, it has a very rich experience for actually finding all those modules that you would use, and you can just basically install those through the command line, which I'll demonstrate here in a little bit. So really nice. It is a very mature package manager, even though it's a pretty new process or a pretty new framework. Excuse me. So IIS Node I mentioned a little bit earlier. IIS Node is a native module that runs Node.js on IIS server. A few really nice things. So you could run Node.js just as itself, in the command line or as a startup process, say on Windows Server, just Node.exe. But running your Node application in IIS actually gives you a number of benefits. We do process management for you, so we actually will do things like scaling out. Say your server has 8 cores, because each process is only running, running a single thread, you want to actually use all of those cores. Obviously, you're not just going to want to have your server running on a single core. So IIS Node will actually handle that scale out for you. We also do things like auto-update your files. We do things like we actually take the Node logs and put them in standard IIS logging. So you have a lot of the benefits of IIS and also a lot of the benefits of Node combined. There are only a few negatives to using IIS Node. One in particular is that you are subject to the limitations of IIS. So one thing, currently in IIS 7.7.5, we don't support WebSockets. So if you're running your application in IIS Node, you are subject to the limitation of IIS, which means you can't use WebSockets. We support WebSockets in IIS 8, so once that's out, and you could do it now also. But basically, then you could run Node.js in in an environment that supported WebSockets. But for the most part, running your application in IIS Node is a super easy way to go. Really scalable. We actually use IIS Node to host Node.js on our Windows Azure Websites product, which we'll show in a little bit. So, Configuration, standard web.config file. We also do support a YAML file for configuration, so if you don't like XML. One of the really nice things about this, you'll notice here that IS node is actually just a standard HTTP handler. What this means is you could actually run a Node.js application side by side with something else, such as, you could use IS to serve static content natively. You could use a .NET. You could actually host a .NET application. Anything IS can do, you can host side by side. So you're not just limited to running Node.js, in its own application in IS. You could combine, mix, and match just by adding that single HTTP handler. So really easy to do and set up. And actually also as I mentioned, so IS and that little diagram there, IS node runs in IS native module and handles multiple scaling out your node server to multiple instances. So in this environment, say you have a four core machine, IS node would actually handle that scale out and run your server on 4 instances of node. So let's jump into a little demo here. I just want to show really quick. An Express Hello World, a really basic website, just running locally on our machine. So let's go back to close my command line. Actually, just do it right here. So let's just make a folder really quick called Hello Express. So to get started, all we really need to do is we're gonna install our first node package. So just an empty folder here, and I want to install the Express package. So npm install Express. And so Express is just it's a pretty powerful web framework. So it does everything you would expect as an MVC framework. It handles views. It does routing, all the things you would generally expect. The nice thing about Express is it does come with a script as well to actually generate the sort of scaffolding of your website. So so let's run that. Node modules Express. And then we'll do npm install one more time just to get any dependencies. So that script added a few additional dependencies. By default, Node uses the Jade view template engine. So what we have here is a basic Node.js application. I'm just going to rename that to server.js. We can run either. Server.js is actually required for running in Windows Azure websites, so I just did that so I don't forget it later. But this is our Express website. It's actually all ready to go. Let's go ahead and run this, and then I'll show you the code. So node server.js, and we're going to listen on port 3000. Let's pull that up in our browser. Localhost. And there we go. We've got a simple Express website. So let's go through a little bit what that is. Let's open folder. There we go. So here's our simple website that was created. Our server.js package basically contains everything like some configuration. We're importing some node modules, and this was all done for us in that script. This is just basically the raw template. We have one route set up. All it is app. So this defines our single route, which is our default route, and then it tells us to use this index, which renders the index page, which we have here this index view, so we can just change that to welcome to TechEd. Actually, let's do it this way. Sorry. title TechEd. And we can stop that and then start it again. So pretty simple. There's our basic web server running on Node.js. This is obviously just running in our single process. We're not using IIS Node or anything to host this. In a second, we'll deploy this application back up to, or we'll deploy this application to Windows Azure and actually see that working as is. See how simple that is. So I want to do a really quick review of Windows Azure and how that relates to Node.js. So Windows Azure is our is obviously Microsoft's cloud hosting platform. We consider this platform to be very flexible, open, and solid, very high availability, flexible in the sense that you can pretty much run any workload in Windows Azure. If you haven't seen, there's been several sessions this week, but we recently have announced things like VMs in Windows Azure, so you can run your standard Windows VMs, but also your Linux VMs in Windows Azure. So pretty much you can do anything, you can run any workload in Windows Azure. It's also very open. It's not just a Microsoft stack. If you're a .NET developer, we obviously have very rich tooling for that, very nice experience. But it also runs other applications. We have a full SDK, which we'll be running through for Node.js. We support PHP, we support Java, Python, all kinds of stuff, and more languages coming soon. So extremely open platform, solid. We give you a high availability. So we have eight major data centers around the world, 2 in Europe, 4 in North America, and 2 in Asia. We also have about 26 CDN content distribution locations worldwide. So a very large global footprint. You basically have access to this multi-billion-dollar infrastructure just by deploying your application there. Our content distribution network is extremely distributed and global. It's the same content distribution network we use for things like Windows Update and Bing. So you have access to that for just merely cents per hour. We guarantee 99.95% monthly SLA. So some of the things I'm going to show you today are in preview. We don't guarantee that SLA when it's in preview, but once we deploy everything to our production environments, we'll give you that 99.95% uptime guarantee. And of course, since it's a cloud platform, you pay only for what you use. So you can deploy very large workloads to Windows Azure and only pay for basically by the hour what you use. So there are a few different models of hosting on Windows Azure. Everyone's obviously used to this, the traditional environment running on your local data center. From that environment, you're responsible for everything from your application, your data, all the way down to your hardware. Whether you're running virtualized or not, that's all your responsibility. We have 3 different models of hosting your application on Windows Azure. The one this virtual machines is something we introduced just a few weeks ago. Virtual machines are just any regular virtual machine running on Windows Azure. We support, obviously, Windows virtual machines, Windows Server 2008, Windows Server 2012. We also support Linux virtual machines. So again, any workload you run in your normal data center, you can run on Windows Azure. We also support something called cloud services. This we'll demo also in the context of Node.js. Cloud service is basically this, we factor out the operating system. So in terms of, you don't have to worry about patching your operating system. So a virtual machine, you're responsible for, making sure your OS is up to date, configuring your operating system, things like that. Cloud services, you have full access to the OS. You can do things like RDP into it. You can install custom software, but we do patch management and things like that. This is what we call our platform as a service offering, where you can actually run your, say, Node.js application in the cloud, and we take care of the things like we provide you with a basic standard configuration for your virtual machine, and we do things like patch management, uptime, availability, all of the things like that you would expect. So you don't have to worry about those things like basically administrating an operating system. You pretty much just worry about your app running and customizing things like your firewall. You can do virtual networks, things like that. And then the next offering we have on Windows Azure, which we'll also demo, is what we call Windows Azure Websites. This is the top of our platform as a service offering, and this is basically the top level. If you're a developer who only wants to put your application in the cloud and not worry about anything like even what web server you're running on, Windows Azure Websites works really well. So it's a very scalable platform. But we abstract everything away from you, the OS, again, all the way up to the web server. So you just basically push your application up to the cloud, tell us how much you want to scale, and it just works. And we'll go through and demo all three of those options. So one thing I do want to say, really, I want to before we go into a little bit more demos. One thing really important: Visual Studio is not required. So we aren't basically building some extension for Visual Studio that says you can use Windows Azure, but you still have to be a Microsoft developer running on Windows. You still have to buy Visual Studio, etc. You can use any IDE. You can use command line. You can also develop Node.js applications for all three of those platforms I showed you on Mac, on Linux. I'm going to show you some command line tools. These command line tools are actually built. These are our Windows Azure command line tools. They're actually built using Node.js, so they run anywhere that Node.js runs. So you can do almost everything I'm going to show you today. You could do on Windows. You could do on Mac. You could do on Linux. So you're not tied to running and doing your development on a Windows PC. So we have a few different ways of basically building up and configuring your applications. We do have PowerShell commandlets for those Windows developers that prefer PowerShell. We have a very rich client library of PowerShell commandlets, so you can actually administer, create all your websites, your servers, things like that, all from the client. Obviously, PowerShell runs only on Windows. And then we also offer these Node.js command line tool, the CLI tools. And these, like I said, you can run anywhere: Windows, Linux, Mac. And they basically, you can create and configure and manage your websites, your virtual machines, deployment settings, all that sort of stuff. And you can do that, again, not dependent on Visual Studio or Windows 7, 8, whatever, or XP if you're still using that. So as I mentioned, we're going to actually start at the top of that stack that I showed you: the virtual machines, cloud services, and websites. The top of that stack is our website offering. This is the simplest offering to get started. We actually do give you free websites. We give you up to 10 free websites on here, and you can scale these up basically as much as you want to. In our preview offering that we just announced a few weeks ago, we do have some limitations of scale. We only actually let you have 3 instances. This is again like an early preview for it. Once we hit general availability, you'll be able to actually scale up these Windows Azure websites that I'm going to show you to almost unlimited scale, just like any other part of our cloud offerings. Windows Azure websites support a variety of deployment options: Git, FTP, TFS. We also, again, you can host sort of the whole. You can host ASP.NET, Node.js, PHP apps in Windows Azure websites. So again, we support a variety of different frameworks, all the way up to classic all the way down, I guess, down from classic ASP.NET. Our ASP pages all the way to .NET, all up to Node. And then we've got more coming soon. We'll eventually support Python and things like that. A variety of different publishing methods. All these are grayed out because we don't care about them because we're Node developers. Git is the one we care about. So we do support FTP if you want to use that, web deploy. TFS, I can't imagine too many TFS developers are also Node developers. I don't know if that would work. But we're going to talk about using Git to deploy to Windows Azure in this session. So the next thing I want to show, we're going to take that application that we built and ran locally and actually just deploy it up to Windows Azure websites. So I've actually started with a fresh installation of our CLI tools. Can everyone see that? Is that okay, or should that be bigger? Good? Bad? Okay. So let me just stop that. So this is a fresh configuration of our CLI tools. I want to actually show you the full end-to-end experience of how you would get started on Windows Azure. I already have them installed. I'm not going to make you wait and sit through that. So first thing to note here is we have this very fancy ASCII art here. This is very warm and inviting, and everyone should like it. Okay. So our Windows Azure command support basically creating all of the things I showed you: virtual machines, cloud services, or websites. You can manage things like virtual machine images and disks. So the first thing I want to do when I'm starting off is actually import my account. So what this is actually a published setting. It's basically a certificate file that's going to authorize your machine to actually manage your Windows Azure account. So Azure account. And we have a few different options here. Basically, we're going to launch that in the browser. So we're going to do Azure account download. And So we're going to go to our new Windows Azure portal, which hopefully everyone's seen by now. Otherwise, I'll show it a little bit. And, oops, that is the wrong account. Hang on. Let's copy that and go to in private so I get my demo account. So we're just going to download these published settings. I just want to save those to my temp location, which I have all my demo stuff in. So again, these are our published settings, which are basically just a certificate. We only have to do this one time. We're going to import these into our command line, and then we're actually going to have full access to our Windows Azure account. And that's actually the only thing we really need to use the portal for, or the website for. So if you're the type of developer who only wants to script everything, that's really the only thing we have to do. After we import this account, we no longer have to use the portal. But it is very nice if you want to use it. So we do Azure account import. And then we specify the location, dtemp, I called it dp demo publish settings. Oops, make sure I named it that. Yep. So we've now imported our published settings, and now we have full access to our Windows Azure account. So we can do Azure, so actually we've got so we have this Hello Express. The one thing I do need to do before we deploy this is actually change one thing. So we're listening on we need to listen on a different port, process.env.port. So that's a variable that Windows Azure is actually going to pass into our server and tell it what port it's listening on. Let me just go ahead and save that, and let's save that Jade file. And so now we can actually take that file we just created, or that site we just created, run Azure site create TechEd Europe for make sure. And then what we're also going to do in the same command, so the Azure Site Create is actually going to go up to the Windows Azure using our REST APIs, create the website, and then that switch there, the Git switch, is actually going to enable Git publishing on that website and set up our local directory where we're at. To actually, it's going to do things like add the remote, so we'll actually be able to publish right up to Windows Azure. So it's looking for locations. It's going to use the default, I don't remember what the default location I have set. It's probably East US. And then it's going to initialize our Git repository and add the remote. Waiting for the site to create. And our site is made. So now all we have to do is let's do a git commit initial source. So we're committing to our local repository first, and then we will, oops. So I just committed our very simple website to our local repository, and wait, I'm in here. Hello Express. Did I? Yeah, git ignore. Perfect. And one thing you will notice is that, oops, did that not? Oh. Okay, hang on. Let's view this in a proper text editor. There we go. So one thing you also will notice here is, and I'll show this in a second, is that for those that aren't familiar with Git, there's a git ignore file, which basically tells us which files to exclude. So the Windows Azure command lines were actually smart enough to add several files. One is Azure Air, which is basically where some error logs get put if we're running locally. But the other one that it excluded is our node modules. So one of the really cool things that we do when you publish to our Windows Azure websites is we'll actually download the modules for you. This means you only actually have to deploy your core application. There's a package.json file which contains all your dependencies, and we'll actually go when you publish, after you publish that to our servers, we'll download those on the server, and we actually have those cached so that they're very fast to download, which means you're actually only publishing your very small application's code, and the publish is going to be very quick. So let's just go ahead and actually publish that to Windows Azure. Git push Azure master. And then it's just asking my credentials for my deployment credentials for Windows Azure. And then we see our app is publishing. So that running npm there, that's actually going and looking at our package.json file and downloading those onto the server. So we didn't actually have to upload those, which is why even on the not super fast conference internet, we only actually had to upload a few files. We just uploaded actually about 5 or 6 files. So really small upload, happened really quickly, and that's actually it. Our site is created and uploaded to Windows Azure. Now let's just go Azure Site Browse, and opening that in the browser, and there we have our simple Node.js application published to Windows Azure. Let me go back to the portal here to show what that looks like in here. So this is for those who haven't seen, this is our brand new HTML5 portal. This also, of course, doesn't require any plugins. This runs on Windows, Mac. Obviously, it's just a web browser. Also, actually works if you really want to. It works on your mobile phone. It also works actually really well on an iPad, which is nice. So this is the website we just created, TechEd Europe 345. And basically, with these websites, we get monitoring, we get all this diagnostic information, we get scale, which I'll show in a little bit. So with Git deployment, we also have this deployment history here. So we see one active deployment. Let's actually go ahead and make a change to this site, and then see what happens. See something that's pretty cool. So welcome to, let's be a little more specific, TechEd Europe. So let's go ahead and change that file, and let's git add, git commit, updated title. And let's just go ahead and push that back to Windows Azure. Git push Azure master. And enter our deployment credentials. Running npm again, and the thing you will notice here is this is an incremental deployment, so we're only pushing that diff up there, and Windows Azure is smart enough to know that we don't need to download. It's thinking, but so you notice there it actually didn't download those packages again. So a very fast deployment, just that diff deployment, and let's go ahead and refresh that site. Refresh. What did we do here? TechEd, that's the right one. Is this cat? Deploy succeeded. Let me go open this in Chrome. Is it cached? Strange. Okay, let's do that one more time. Otherwise, my rollback isn't going to look very exciting. Let's make a little more different change. So we see our site is deploying there. Hopefully it updates this time. And once that is finished, Okay, so we have 3 deployments now. What in the heck? Hang on, let me just try one thing. Stop. It is still in preview, so we're working out a few minor bugs. There we go. Okay. Perfect. So there we go. We've got now both of our changes appeared. So we actually now have 3 different deployments. And one of the really nice things about this is we have now this deployment history. If I say do that deployment and change my mind and I didn't actually like that, I can actually click one of our past deployments and redeploy that. And that will happen in just a few seconds. And now that should be active. And let's see if that top. Okay. And we will stop and start it again, which we don't normally need to do. I don't know what's going on. And there we go. We've got our. No, did that change? Oh, yeah, it changed here. Okay. So we went back now and changed that. So normally you wouldn't have to do that stop start. I'm not entirely sure why that's happening. I actually think they might have done a deployment last night, conveniently enough, right during when everyone's demoing it. So we're iterating this very rapidly. We'll have that worked out in no time. But basically, I think that's really cool for those people. The few of you that have used Windows Azure before, one of the really striking things about this is how fast the publish is. I've actually done tests with this. And we do a couple things that actually I've used some of the there's a variety of competitors that do something very similar, this Git deployment, and because of the few things we do with our deployment, including caching our the node packages locally, I've actually done some tests, and this actually happens not that maybe 1 second matters, but usually deploying to Windows Azure websites is actually like a few seconds faster than some of our competitors. So for those few of you that have used Windows Azure before, used cloud services, and know that sometimes they've taken 5, 10, 20 minutes to deploy sometimes. This, I think, is a breath of fresh air, right? You can deploy your website in seconds and actually scale them in seconds also. So let me go to, actually, let me switch to shared here. So so by default, you're going to be running your website in a shared instance, which I'll explain, or actually, I have slides first? Yeah, I have slides. Let me just do it. So initially, your site's going to be running in what we call shared mode. Basically, this is we give you 10 shared instances for free, 10 shared sites for free that are running in a high density shared server. So this is a shared hosting model by default, where you're running your application on the same servers, on the same virtual machines as other customers. However, we do have some really interesting underlying technology with this. This isn't just normal app pool, shared hosting compared, like what you're probably used to with especially .NET shared hosting. We actually have a full application isolation model where we're running a virtualized instance of IIS in this server. So your app, for .NET developers, what this means is you can run your application at full trust. You are completely isolated. As far as your app's concerned, you're the only, your app is the only application running on that server. As far as it's concerned, it has the whole operating system to yourself. You can pretty much do anything under the .NET model of full trust. You obviously can't do things like edit the registry, stuff like that. That would be bad for the other people on the server. But this is a very powerful, very secure hosting model. By default, like I said, you're on this shared instance with one core. If you want to scale that up, you can scale that up to multiple instances, and what these instances are still shared resources, but you get a certain amount of. We haven't published exactly what our bandwidth and memory allocations are for those, but you can sort of think of these as maybe you're getting 1 core, 2 cores, or whatever, partial cores, and then you're getting additional memory and additional bandwidth. And I can scale that up from 1 to 3 in just a few seconds. And my site will still be live. None of these scaling operations take your site down. Looks like we just hit a random news server, so it took a second to load. But one thing we also offer is a reserve mode of this. Same model, but you own the you own the servers. We'll give you a little warning that's going to cost money, and you can choose the different server sizes. So you'll notice here these are actually, for those familiar with Windows Azure development, these are 3 of the 5 sizes we offer for things like cloud services and virtual machines. So in this, I'm going to say, let me go ahead and pick, I want to scale up to 1 medium instance. So I want to run this site on its own server, 2 cores, 3.5 gigabytes of memory. Save this. And again, this will only take about 6 seconds to do, or less. And let's refresh that site. And that same exact website is now running in a second here on its own server, completely isolated from other customers. So you've got a couple different scale options. I'll explain in a little bit. I've got some slides to kind of explain that. But what's happening under the hood, which is really nice for this, is eventually it'll load, hopefully. So what's happening under the hood is we actually have we have a shared storage environment. So what we're actually doing here is we're not moving your application around. All we're doing is making adjustments in our load balancer that are our router, the load balancer and router that actually sends traffic to your particular site. And all we're doing is saying, okay, now you have your site on server A. If you scale up to 3 nodes, you might have your site on server A, B, and C. If you scale up to reserve mode, we just move over to that reserved instance. So we're not moving your site around. It's actually just small configuration changes on the servers, which is why this happens so quickly. Usually so quickly. So and all of that normally happens with. What time is it in the U.S.? Hopefully they're not doing it like a deployment right now. Sometimes they do deployments usually at like 2 to 3 in the morning, which I think that's what time it is now. That would be funny. Okay, so anyway, you'll take my word for it that this happens without. So this all happens without taking your application offline. So we won't actually. So while those 5 or 6 seconds while we're spinning up those new instances, we'll keep serving traffic to your old one. And then as soon as the new instances are ready, our load balancer just makes a small adjustment and starts sending traffic to the new server. So a very powerful and somewhat functional hosting platform. All right, we'll move on. I assure you it works some of the time. So, again, just a reminder, this is in preview, so we are working out some of the bugs. It might also be internet issues here, I don't know. So anywho, we'll switch back to the slides and go a little bit more into that. So that first operation I did, I deployed my site to the shared instance. It's a single shared instance, again, with multiple customers. If you wanted to scale, the second thing I showed was scaling that up, and all we did was basically made, again, a configuration change and say, okay, we're now going to run this on 2 servers. If I want to move up to reserved, we're going to take that same site. We're going to provision your own reserved instance and move your site over to that, and you'll have the full power of that virtual machine. Now, these are the exact same types of virtual machines. So even though the one thing to note here is even though that reserved instance is all yours, it's still running under the same hosting model. So you still don't have access. Like you can't install custom software, things like that. This is still very much a high-level platform as a service offering. We have other services which I'll demo in a bit if you need more access to the operating system. But these servers are provisioned and managed in the exact same way as the shared instances. It's just that you get the full resources. And you can also scale those up to multiple instances. The other nice thing about the reserved model is you're free to actually host multiple websites on those same reserved servers. So we don't restrict you to, say, one site running on one reserved server. If you're a hosting customer that wants to have, for whatever reason, you want to have 2, say, medium virtual machines that are just yours, and you have a lot of little websites, or say you're an app developer that develops for your customers, and your customers, you just want to put all your customers on single virtual machines, you're free to do that as well. So it's very flexible in how you want to scale this. You can scale out with our shared model. You can scale up with our reserve model. So a lot of different choice there, and there's no. It kind of just depends on what your application's needs are, and what you prefer. So that's Windows Azure Websites. There's not a lot to show with that. It's quite simple. Just publish your application to the cloud, and it just works. So we're running What time? Oh, we're running way behind. I'm going to have to speed it up a little bit here. Okay. So our next service is Node.js. Node.js talk here. So our next service is cloud services. Cloud services are what Windows Azure has been for the past couple years. This is still our platform as a service offering. This is that middle level, which I talked about earlier. These are still virtual machines running in the cloud. We still abstract away some of the operating system for you. We do patch management, configuration, various things like that. We have like a health agent that runs on those machines. We will take them offline and move them around, all kinds of stuff. These are stateless. So they can sort of be taken down and moved at any time for various patching, hardware failure, things like that. There's two different ways we run Node.js on these cloud services. One is called a web role. A web role runs IIS, and it runs your Node.js application in IIS node. Again, subject to the limitations of IIS. The main limitation that developers are concerned about these days is WebSockets. We also have a worker role. Worker role is just, you can think of this, it's a whole virtual machine, but you can sort of think of this as like a service. We're running just a single instance of Node.exe in this end, and it's just running as the entry point. So you say, I want this file like server.js to start, and just run Node.exe. So this you can do anything you can do with Node. So you can actually run a WebSocket server in here because you're running outside of the Windows default HTTP stack, which IIS is running on. You can deploy these using the PowerShell commandlets or the CLI tools, and so on. So here's just really quick those two different roles. These are full virtual machines. In both of these virtual machines, you have full access to the operating system. So you can remote desktop into these, which you can't do on Windows Azure websites. That's again a very high level platform offering. And cloud services, you can remote desktop in. You can install software. You can script things. You can edit the registry. Anything you want to do. I mean, you have full access to the machine. Again, the web role, it's running IIS. Running those node, running IIS node, and then running your server on Node.exe, scales out to multiple instances. The worker role is not running in IIS; it's just running in that role entry point. We start a single instance of Node.exe. I think what do we go till 9:45? I think I don't know if we have time for this. So yeah, let me just do really quick. So you can create these. You can create these with the commandlets also. Create and deploy them. So Azure service. So you can create. Yeah, let's actually skip this. So actually, sorry, you can't. I forgot. You can't yet create them with the Node command line tools. We have to switch to the PowerShell tools. I'm going to actually skip this because we are running a little short. I'm going a little slower than I had planned. I think I'm a little tired, maybe. So anyway, basically the idea with that is the same stuff we showed you, the same Node code and everything. You can deploy to your own OS so that you have full access to it. So, for example, if you actually wanted to install something or wanted to run like some other background process or something, the cloud services, you get a lot of the benefits of like Windows Azure websites with a little more flexibility. So you don't have the sort of we maintain the full stack. Like Windows Azure websites, all you need to do is deploy your application. Anything else that could go wrong or needs to be configured, we take care of that for you. Besides that, you scale. With cloud services, you have a little bit more flexibility, but we still take care of a lot of the nitty-gritty of managing an operating system for you. The third one is Windows Azure Virtual Machines. So Windows Server, Linux. Obviously, this is completely flexible. This is completely yours. We don't do anything like the health we don't have like a health agent on your machine. We don't do OS patching. These are just virtual machines running in the cloud. Do what you will with them. We do support virtual private networking, so you can actually, even between cloud services and virtual machines, you can build networks in the cloud that are all connected together. We have a few different images right now at preview. We'll have more coming over time. We have Windows Server 2008 R2. We also have a SQL Server. We have Windows Server 2012 release candidate, and then we have 4 varieties of Linux. you should expect. I mean, you'll expect more of those. We'll have more coming over time. Potentially more Linux distributions. Potentially more stuff like with this SQL with the Windows Server with SQL Server already packaged. You could expect more things like that with prepackaged software built into it and configured. So you saw a little bit earlier about the reserved instances of websites, a few different sizes of virtual machines. These are the same sizes for our cloud services and our virtual machines. We go all the way from this extra small instance, which is actually a shared core, 768 megs of access. After Windows, you've got about 500 megabytes of access. We give you a little bit of bandwidth and disk, all the way up to an enormous, 8 core, 14 gig of memory, and 800 megabytes of bandwidth. You can have a ton of persistent disks. Each disk is up to 1 terabyte in size. Oh, that's actually also worth noting. Sorry, I left that out. So the cloud services I mentioned are stateless. You need to store, if you're storing images or something, if you have a content, if you have content that's edited or changes with your site, in Windows Azure websites, those are persistent. In Windows Azure Cloud Services, you need to actually store those off your application, such as in our blob storage or in table storage or in SQL or anything like that, or in MySQL. Windows Azure Virtual Machines are also persistent. So Cloud Services are the only ones that are not persistent. In virtual machines, you can create these disks. They're actually blob storage. They're actually mounted in blob storage. So if your machine goes down, we'll remount that disk and you'll continue back on. They're geo-replicated, all kinds of stuff like that. So for node developers, the most common things for using Windows Azure Virtual Machines is for deploying sort of the applications that people typically use. Redis, MongoDB are two examples of that. Now that you have the full access virtual machines, and especially now that you have Linux, which a lot of the tools and backend servers that node developers use, you can now deploy those services in, say, a Linux virtual machine, and then run your website, your front end in like a cloud service or a Windows Azure websites. So you can of course mix and match all of these services. If it makes sense to you, you could deploy something like Redis in a Linux VM, and then you could deploy the front end of your site in Windows Azure websites. So let's go ahead and actually just really quick, I'll show how easy it is to create virtual machines also. So I've got a few created. I think we're running too short on time to show. But basically, I've created 2 virtual machines. They're both Linux virtual machines. One's running Redis, one's running MongoDB. If I want to create a new virtual machine, super easy. I can basically pick whatever flavor I want. Say I want OpenSUSE. Set a name for that. My new VM. A username. The size of it. Let's do a big one. I don't pay the bill, so use as much as possible, right? My CC VM 1, 2, 3, storage account to use, and we can select where because let's select this one. It is the closest data center. We'll just ignore the availability set, and that's really all that's really how easy it is to create a virtual machine. And we could SSH into this. We could actually do the same thing with our Windows Azure command line, Azure VM. This we do have full support. We can create virtual machines. We can list our virtual machines, shut them down, all kinds of stuff. We can actually manage the endpoints, which is basically the ports and stuff that are open. We can manage virtual disks. So we could actually attach a bunch of disks to like this. So say actually this virtual machine, or so we right now are basically each of these machines I created have 1 disk. We could very easily create as many disks as we wanted to. Oops. And then this is to upload a VHD. So I could upload a VHD with a disk on it. and upload. And basically, again, I could get a huge amount of storage, up to 1 terabyte per disk, and basically as many disks as you wanted to. You can upload your own images too. So say you frequently build Node.js applications that use MongoDB. You could actually create a VM, capture that, or even upload upload an existing VM and have basically a template image ready to go. So when I showed you from that gallery where I created like the Linux VM, excuse me, you could actually have your images and disks there. I don't actually have any, but where you would get this sort of similar list, and you could have, like, say, your default MongoDB server or cluster or whatever ready to go, so you could deploy and create those over and over again. Same thing, with anything. You could do both. You could do that with both Windows and Linux. So we've got about 11 minutes left. Let's move right along. So those are really our 3 core offerings for hosting on Windows Azure. We've got, again, the Windows Azure websites, very easy to get started, very simple. We've got cloud services, and then we have Windows Azure virtual machines. So depending on what your needs are, you can host your Node.js application or backend services on all 3 of those. Windows Azure is also is more than just hosting computer or web infrastructure. We also have a variety of these platform services, databases, storage, all kinds of things, caching, identity management, content distribution, which I mentioned earlier that we have about 26 locations around the world for hosting your CDN. We do virtual networking, all that stuff. So most of these services are also available to Windows Azure. So we have available to Node.js. So we have a Windows Azure Node SDK. We support all of our storage infrastructure, blobs, tables, queues. We also support Service Bus in there, so we can use Service Bus queues and topics. And that's available with the Node package, which is actually the same package. This npm, this Azure package is the same thing I was just showing you with the Azure command line. So both our command line tools and our actual SDK are available in that same package. We also offer a driver. This is still in preview, but we also offer a driver for SQL Server now. So you can actually use, if you want to use SQL for database storage, don't want to manage your database, like don't want to prop up your own SQL Server or MongoDB or whatever, or run MySQL and say a Linux VM or Windows VM, you could actually use our Windows Azure SQL databases. And so this is Windows Azure SQL databases are a service. All you do is create a database, and we manage that for you. So it's a completely managed data service, and we all now also offer a native driver for Node.js. It is in preview still, but works very well. So again, Windows Azure Storage. Basically, storage in the cloud. We have table storage. We have basically a schemaless NoSQL storage mechanism. We also have blob storage, which just stores generic blobs. It's all available via REST API. We've wrapped those around with the Node.js SDK. So the next thing I want to demo is actually let's use that storage library. I want to demo this from WebMatrix. Actually, how many people have used WebMatrix before? Not very many usually, which is usually the case. And I actually haven't used WebMatrix too much before either until our most recent release. So about 2 weeks ago, when we released the Windows Azure updates, we also released an update to WebMatrix, WebMatrix 2. There's actually some really cool things in here for Node developers. So normally I've been doing my Node development in Sublime Text, which is it's not free, but it's just a really simple IDE, similar to kind of like TextMate or whatever, but it runs in Windows and Mac. Which is great. It works really well. I use the command line. But WebMatrix actually provides a really nice experience, and actually also provides some really interesting features for Node developers. So the first thing you'll notice is we actually support a variety of different languages in here. We have a variety of different sites. So let's actually go ahead and just recreate that Express site we made through the command line, but let's create that through Node.js. So let's new Express site, download the template, configure that. And so here's our Express site. So one of the first things you'll notice is that, let's open our server.js file. This is the exact same server.js file we were using before. But one of the things you'll notice with this is we actually support IntelliSense. And this isn't just JavaScript IntelliSense. We actually support Node.js IntelliSense. So you'll notice here we don't have document. Our Web Matrix is actually smart enough to know that if you're in a server-side Node JavaScript file or a client-side JavaScript file. So we also have we can also create a client-side JavaScript file. And we get the normal things like document, get element by ID. So really rich, really nice IntelliSense here. Again, I've actually never used, I've always thought Web Matrix is a little bit of a, toy. I mean, I've been a .NET developer. I've used Visual Studio. Web Matrix always seemed kind of like, meh, wasn't really interested in it. I either, again, use Sublime Text or Web Matrix. But I think with these new features, it's actually something that's pretty cool and worth looking at. One of the really cool things, though, with this is actually how we extend this IntelliSense. So let's actually open a command window here and install npm install Azure SDK. So it's actually just installing that node module for Azure right there. Just give that a second. Kind of a lot of dependencies. We'll download it. Okay, cool. So if we want to use that Azure SDK, we actually parse the node modules directory, and we actually include we include IntelliSense for the modules you have installed. This isn't just a list of all modules. These are only the ones that are installed or the native modules. So I think that's pretty awesome. And then we also give you IntelliSense in that module. There we go. Oops. All right. Hang on. So let's actually go ahead and create. I don't think I'm going to have time to deploy it, but let's do a quick demo of table service. So we have Azure create table service, and then we can do like table service dot create table if not exists, table name, TechEd, function error. And that's it. So we can create a table. We can do like table service, insert entity, table name, TechEd. Oops. And partition key. And we only have like 1 minute left, so something, and row key, oops. So this is our simple. So basically, again, I'm not going to finish this because we're like 2 minutes away from being done. But basically, this is our we can create table service. So again, we have all these parts of the SDK, table service, Windows Azure service bus queues, and then also we've got the SQL Azure modules. So publishing also from Web Matrix is super easy. Let's actually go ahead and quickly create a new site. We can just create up to those Windows Azure websites. And let's just do something really quick and create. So we also support this web deploy publishing if you're using Web Matrix. So if you like Git, that works really well. But we also have other options you can choose. And let's just go ahead and download this publish profile, which again contains like our credentials. Save that to our temp directory. And publish. Import those publish settings. And save. Don't need to check compatibility. And Web Matrix actually also supports incremental publishing. The first time we're going to publish, it's going to upload everything, the whole deal here. But after that, it's incremental. So we can publish really quick. And you see it's uploading there. Uploading still. All right. And uploading still. Okay, let's just pretend this finished. Anyway, so that's basically publishing from oh, there we go, it's finished. So two different ways to publish your site with Node.js. You can use web deploy, you can use Git. You could also use FTP again if you really wanted to have a horrible experience. So there we go. We've got our second Express site published. So we've created 2 sites, published them to Windows Azure websites. Pretty simple. We can use all of our. Let me just skip through here. Again, we can create. We can use Windows Azure Service Bus queues. We can use table storage, and that's about it. Please submit an evaluation. That's always helpful. And so yeah, that's basically about it. You saw the different ways to create Node.js. Like I said, everything on here that I showed except for Web Matrix, which is obviously only a Windows product. Everything that I showed you we can do from a Mac, from Linux, from Windows. So if you're a Mac developer, you can absolutely participate in this Windows Azure ecosystem. So hopefully that gave you a little bit of an overview of what you can do with Windows Azure and Node.js. There's obviously a ton more. I mean, we could go on for hours and hours, but hopefully you at least learned enough to get started. Just go to windowsazure.com and you can click Develop and you can click Node and you can find all the resources. We've got a ton of different samples, things like that. So that's about it. Thank you all for coming, and hopefully you enjoyed it.